If I look at this, my line conductor or my hot is 22 amps and 17 amps. The difference or the unbalance between 22 and 17 is 5. And look what's established on our neutral current is that 5 amps. So now that I know what direction this neutral current is going and the direction of these values, I can also place a polarity for these values. And I know that this is flowing negative through positive. Current is flowing from negative to positive through that source. Okay? Look at the direction of current here. It is flowing negative to positive. It's actually different. It's flowing in a different direction. It is flowing in the same direction from here, but it is flowing back to our source at this point. On this, I will have a negative and a positive. And for me, the last double check that I like to do, as I've worked right to left through this circuit, what I like to do is my last opposition here before my source, this opposition, or sorry, this polarity should match the polarity that I've given at the source. This polarity here should match the polarity that...
Yung kung titingnan natin, okay, positive, negative, positive, negative, and then itong taas at sa kababa 240 volts. Okay, 240 volts itong isang linya, pares ito 240 volts. Ngayon, kung titingnan natin, yung gitna ay pwede pala positive at saka negative.
Hi, good morning. Welcome po sa ating Mounting Channel. Ikaw man ay Pinklawan o DDS, welcome po. Saan ka mang panig sa mundo ngayon naroroon. Ang unang topic po natin ay patungkol sa basic inventions, yung kagamit-gamit sa pang-araw-araw. Minsan po ay na-feature na po tayo sa Rated K at na-feature din tayo doon sa Channel 25 sa Pambansang Almusal. Ang pangalawang topic po natin ay patungkol sa health, paano tayo maging healthy na walang gastos. At pangatlong topic po natin ay patungkol sa entrepreneurship, paano tayo kumita dahil panahon po ngayon ng taghirap. At pang-apat na topic natin ay mga trending issues, kasali na rin ng mga politics dahil yan po ay mga bagay-bagay na nakakaapekto sa ating buhay. Kung ngayon ka pa lamang nakadaan dito sa ating channel, huwag kalimutang mag-subscribe at i-click din ang notification bell upang ma-updated kayo sa ating mga bagong upload na mga videos.
Dahil po ang purpose natin ay gagawa tayo ng energy saver, mag-umpisa muna tayo sa principle. So, siyempre, yung ating mga kuryente nanggagaling yan sa power plant. Doon sa power plant, mayroong mga turbina, yung iba malaking diesel plant. So, ito, representing engine ito, malaking engine. Doon sa engine na yon, may umiikot yan na generator. Ang nagpapaikot sa mga malalaki, yung mga turbina. Yung mga malaking engine naman, mga bunker plants, diesel engine na malalaki, so mayroong generator dyan, o umiikot. Ngayon, ito, representing ito yung generator. So, dun sa generator, mayroon yan na magnet. Mayroong induced magnet na kinakargahan lamang ng magnet, or doon sa mga maliit, mayroon niyang talagang pwedeng magnet lang na natural magnet, gagana yon. Pero sa malakihan, induced magnet galing sa battery. Ngayon, doon sa generator na yon, mayroon yan north at saka south. At may mga coil yan doon sa ito yung alternator, so north at saka south. So dalawa yung magkatapat dito sa kanyang stator. Ito naman yung sa loob na armature, ito yung umiikot. Itong sa labas casing, siyempre stator, maintain yan. So ganito, yung north naman, pag nakaharap siya dito sa stator na ito, pag nakaharap siya, siyempre ang lakas, kahil malapit nagkaharap sila mismo, ang lakas ng voltahe niyan, ang lakas ng puwersa. So habang nandiyan sila nagkaharap, ang lakas, kung ito yung voltahe, zero itong gitna, at ito yung pinakamalakas na positive, habang nandito siya, nandito. Ngayon, pag umikot siya, papunta dito sa zero axis, kumbaga ito yung axis, zero axis dito, at ito naman yung zero. So pag ikot niyang ganon, ikot, so lumalayo siya dito sa kanyang kaharap na stator, so hihina. So habang pababa siya, kung ito yung pinakamalakas, pababa dito sa zero, hihina siya hanggang maging 0, wala nang lakas kasi sobrang layo na. 0. Ngayon, pag lagpas niya dito, 0. Ngayon, axis 0, axis ito 0. Ngayon, pag ikot niya ulit, pag pababa dito, mayroon naman kaharap na naman siya dito, negative naman kasi kaharap naman niya dito yung kabilang pole. So, at ang ating pinag-usapan lamang dito ay single phase muna, single. Although maraming pole yan, halimbawa 6 pole or 3 pole o 8 or 12. So, pero ang ating para maintindihan po natin, single phase muna yung isang line para maintindihan natin. So, yan, umikot nga siya. Pagdating dito sa baba naman, so negative naman ang kanyang charge. And then, diretso naman siya, negative charge dito, diretso. Pagdating dito, 0 uli. And then, pagtaas uli dito ay positive uli. So, ganun pa. Kaya ang takbo ng kuryente ay ito ang tinatawag na sine wave, taas-baba. So, ito yung kanyang 0 or 0 point volt. So, ito pinakamataas, ito ang pinakapataas na positive, ito naman ang pinakamalaki pero negative. So, taas-baba. Ngayon, itong kabila naman, habang nandito yung north, ang kanyang south naman, nandito yung south, yung kabilang dulo niya, kasi ang magnet ay north at saka south, ang kabila negative, nakaposisyon sa negative. Ganun din naman, pagka nandito yung position niya, south, negative charge. So, pag ikot niya dito sa banda dito sa axis naman, 0. Ayan o, from negative, 0. And then, pagpunta dito sa taas, positive naman siya. At kaya salubong yung dalawang takbo ng kuryente, yung north at saka south, magkakasalubong sila. Ngayon, paglabas niyan, ito ngayon yung ating, kung paglabas niyan sa planta, magiging mayroon ng linya yan. So, ito na yung gagawing linya. Ito yung pinakamataas. Ito yung sa ating mga linya sa mga distribution, line 1, saka ito yung maging line 2. So, ang ating mga voltahe sa ating mga distribution line ay 240. So, mayroong minsan, may kalahati dyan, may ground, 240, kalahati, 120 or 110, magkabilaan. So, 110, 110, ang sa kabilaan sa line 1, line 2 ay 240 or 220. Yun ang range ng kung sakaling bumababa yung yung voltahe, 220 hanggang 240. Okay, paglabas niyan, so galing yan sa planta. Ngayon, siyempre, pag malayo na ang takbo, dumadaan sa transformer. So doon sa mga linya, ang dami ng mga makikita natin yung mga tower ng electricity. So mayroon yan poste. So pag yung mga tower ng pag tumakbo na sa distribution, kung mayroong poste, makikita natin mayroong mga transformer. Kapag umikot tayo, makikita natin yung mga transformer. Nakikita natin yan, tapos may mga linya yan. So line 1, line 2, doon magtatap naman. Ngayon, itong transformer, mayroon yan ground. Okay, pangatlo yung ground. So, kung ang ating linya ay 240, minsan yung line 1, i-connect, pag itapat mo yung kabila, kung titingnan mo sa reading yan, line 1 at saka ground, 110 or 120. Line 2 naman ang ground, 110 or 120. So, yan yung mangyayari. Ngayon, pagka minsan naman, ang ibang mga distribution, wala yung kuryente itong line 2. Itong line 2 minsan ang naka-connect sa ground, tapos isa lang ang buhay. So itong pag ground itong line 2, so ibig sabihin yung line 1 ay antimano 220, 240 na. So yan ang mga ibang situation. Pagdating naman sa ating mga pagpasok sa ating mga residential, so bago pumasok yung kuryente sa ating bahay, mayroon dadaan siyempre sa meter. So ito yung ating watt meter. So ayan na yung line 1 at saka line 2, papasok yon, and then dadaan dito yung reading kung ilan yung konsumo, and then lalabas ulit line 1, line 2, yun na papasok sa ating bahay, line 1 at saka line 2. So yan yung mangyayari. So yung ating mga kuryente sa bahay 220. So sinaksak ko yung itong electric fan, ito ay 220. So ngayon susubukan ko ang ito, susukatin ko itong voltahe nito, yung kalahati lang, yung isang wire lang, kaya itutusok ko dito yung isang linya at re-readingan ko ngayon kung ilang voltahe. Diyan yung isang linya ngayon, ikukunik ko dito sa poste ng aming railing sa hagdanan. Ikukunik ko dito to, ngayon ilan. So ang reading ay 114. Yung mataas ang voltahe 114. Puwit may tumataas pa 114. Kalahati yan. So ngayon ililipat ko uli itong pagsaksak dito sa kabila kung ilang reading. Okay, kukunik ko uli itong kabilang probe sa Okay. Ang reading ay 118. Medyo malabo. 118.8. So mataas. 118. Okay. So ngayon tutusukin ko naman ng sabay itong dalawa. Ayan, 233, 234. 234. Mataas. Okay? So, yan, nakita po natin.
Hello everybody. We're going to look at today is an Edison 3-wire circuit with two loads connected to individual phases and then a load connected essentially line to line. So I want to break this up to make sure we take this nice and slow. We can establish some polarities. We'll do this in multiple videos just to make sure that we can go through this point by point and understand each concept, because really as we go through this we'll have to be able to understand from how one thing is leading into the next. So we can do this with a DC circuit and establish polarity, because it would be constant throughout the operation of that circuit based on how I connect my source. If I have an AC circuit, we can still do this analysis, but it would be essentially the idea of freezing time, stopping the polarity maybe in the positive half of our sine wave, and look at what is taking place at that one point of time. The analogy still works for AC or a DC circuit, both are accurate, and then it helps us to understand what is happening with this conductor itself. So let's say we have a 120 volt source and a 120 volt source. What Edison figured out is that if we connect this, as long as if they have equal but opposite polarities, we'll have these two voltages add together. It applies with Kirchhoff's voltage law, everything follows suit. So let's just make this a DC circuit right now, just as so we can establish polarity a little bit simpler. If it's an AC circuit, it still works, the concepts still apply. We'll just have to freeze time. So let's just keep it a DC circuit. So on my DC circuit, if I looked at the cells that I'm going to use and I established this as my negative terminal of my battery or negative terminal of my power supply, the other side would have to be a positive. Then I would look at this power supply, and if I wanted to connect these so the voltage is added together, I would have to connect them and orient them so my negative terminal was here, that would be connected with the positive, and my positive terminal would be connected here. Then if we actually look, we apply what we may understand already about Kirchhoff's voltage law. If I look at the potential difference across the entire source, it is a negative and a positive. That's what I need in order to establish a potential difference and for those two values to add together. If we want to look at Kirchhoff's voltage law, I could start right here and I could say, look, this is a positive terminal, so a positive 120 plus a positive 120 would equal 240 volts. So if we're going to go back to our AC circuit, a lot of our single phase AC circuits, if we had this taking place, we could see some nominal voltages that could say something like 120/240. So what that voltage is representing, this 120 is an individual line conductor to our neutral or our identified conductor. In this case, it would be a neutral conductor. This 240 volts would represent the line 1 to line 2 scenario of a single phase circuit. So if we're starting from there, what we need to do is talk about our loads quickly. If we look at this load, we're just going to pick some arbitrary values. We're going to look at what is happening with those and how it establishes our polarity. Let's say load 1 is operating at 15 amps. And load 2 is operating at, let's say we're operating at 10 amps. Okay, that's fantastic. That's the characteristic of the load. When I hook it up, I can take a clamp-on ammeter, measure it right on this conductor, measured 10 amps. That's fantastic. Okay, and let's also utilize our load that's connected to our 2 line conductors. Let's say that it is operating at 7 amps. So as I go through this, for myself, what I like to do is I like to establish that polarity. And I like to draw, okay, use some arrows represent what's happening with current. So I'm going to say that 7 amps is flowing through this load. That's what it's operating at. So at that point, entering the load, 7 amps. Well, this is an example of a series circuit. There's one path here. So what's entering this load has to also be leaving this load. So current has nowhere else to go, but it has to travel to this point. So I will have 7 points, and I will have 7 amps entering that junction as well. And I like to trace this all the way back. So what do I have? If I have 7 amps flowing into this load, that means I have to have 7 amps at this point, and I must have 7 amps at that junction. So I have 7 amps flowing through my circuit in that direction. Okay? And I just picked this based on the polarity of my source, and I just picked, okay, I'm going to establish that current is flowing in that direction for this part of my circuit. So now that I have this established, what I can do is actually use the principle of electron flow and determine, well, what is the polarity of this component right here? So you can use this again, conventional flow or electron flow, it doesn't matter. I'm going to use electron flow just to show negative to positive through my circuit. So if current is flowing negative to positive, then this has to be a negative as it's flowing through. I would have a collection of electrons there, and I would have a deficiency at that point. Current is flowing through the load, so I would have a negative at this point and a positive at that point. As I continue, I will have a negative and a positive. What this helps us to do is to see what is happening with the voltage. So if I know that 15 amps is going to be flowing through this load, that's what it's operating at, I can establish the same thing here. 15 amps flowing through the load has to be entering this junction. I have 10 amps flowing through this load. Okay. Well, if I have 15 amps flowing through this load, entering this junction, and I only have 10 leaving, Kirchhoff's current law said, well, it can't just disappear. So what is happening? I am having 5 amps, or the difference, on this conductor. If we understand what the name of this conductor is, our neutral conductor, the whole purpose of a neutral conductor is to carry the unbalanced load. Well, that's the unbalance. That's the difference between load 1 and load 2 is 5 amps. So if we understand that, we can look up here. I have 7 amps that's flowing through this load, and I have 15 amps flowing through this load. So therefore, the current entering this junction must be 7 plus 15. So I would have 22 amps on that conductor. I can go down to the bottom now. If I have 10 amps flowing through this load, that means there's 10 amps entering this junction at this point. So I must have 17 amps flowing on this conductor. Remember the principle of our neutral. What is the whole point of the neutral? It is to carry the unbalanced load. If I look at my line conductor here and my line conductor here, okay, we can call them an ungrounded conductor, a hot conductor. If I look at this, my line conductor or my hot is 22 amps and 17 amps. The difference or the unbalance between 22 and 17 is 5. And look what's established on our neutral current is that 5 amps. So now that I know what direction this neutral current is going and the direction of these values, I can also place a polarity for these values. And I know that this is flowing negative through positive. Current is flowing from negative to positive through that source. Okay? Look at the direction of current here. It is flowing negative to positive. It's actually different. It's flowing in a different direction. It is flowing in the same direction from here, but it is flowing back to our source at this point. On this, I will have a negative and a positive. And for me, the last double check that I like to do, as I've worked right to left through this circuit, what I like to do is my last opposition here before my source, this opposition, or sorry, this polarity should match the polarity that I've given at the source. This polarity here should match the polarity that
Ayon sa diniscuss noong tao na ang sinasabi niya na ito nga ay 110 volt. So ito ay 110 volt na supply. Dito naman ay 110 din, ganun din. So yung kung titingnan natin, okay, positive, negative, and then itong taas at sa kababa 240 volts. Okay, 240 volts itong isang linya, pares ito 240 volts. Ngayon, kung titingnan natin, yung gitna ay pwede pala positive at saka negative. Okay? Pwede pala maging itong linya na ito, pwede maging positive at saka pwede maging negative. So anong clue natin? Anong clue? So dito sa yung sa ating sinukat na voltahe sa aming linya, nakita natin yung kalahati, okay? Yung kalahati na yung isang linya lang. So kung nung sinubok natin, yung isa lang ito tinusok ko sa dito sa isang linya at doon sa aming handrail, sa aming hagdanan 110. Ganun din dito sa isa 110. Tapos nung magkasama itong dalawa, pinaris ko to 30 plus. Okay? Meaning 240 volts. Ngayon, yung ibang bahay sa mga ibang linya, mga probinsya, 240 nga ito, pero itong isang linya lang ang buhay. Yung isang kabilang linya ay naka-ground, kaya ito zero. Walang kuryente, ito lang ang isa ang may power. Kaya ngayon dito sa amin, kung ganito din ang pagka-sit up sa inyo, yung kalahati kasi ground nga dinampi ko sa doon sa railing 110 or mahigit pa 110 ay 114, 118. Ganon din sa kabilang butas, ganon din ang registered. So ang kahawig nito, kung sakaling tama ang kanyang explanation ng tao, na itong linya pala na ito, yung gitna na ito, ay pwede pala maging positive, negative or positive, ayon doon sa explanation. Ngayon, ang purpose na ay gagawa ako ng, yun nga, yung energy saver. So, anong gagawin ko sa energy saver? So, itong, dahil at ang mga linya natin ay alternating current, okay, ganun nga ang kanyang wave, sine wave. So ito, sine wave, kaya ito, naka-ground nga ito. Wala naman tong wave. So hindi natin alam kung sine wave ba, wala. Basta grounding lang ito. So ang gagawin ko nga ay, papakinabangan ko lang yung, kasi hindi naman pwede na, hindi tayo kukuha ng power. So itong kalahati lang ang pakinabangan ko. Itong kalahati ay patay. Ganun din naman doon sa kabila. Anong purpose? Para lang kung sakali lang makasave ng energy. Yun nga, pero pagkakalahati lang, patay ito, at patay naman dito sa kabila, hindi gagana yung electric fan pag sinaksak mo. Kasi patay, di kaya. Pero ang gagawin ko nga ay gagamit ako ng ground. Kahit saan ground, magbaong ka ng rod sa lupa ng 1 metro. Tapos ito na yun, bagbaong ka ng ground. Tapos ito, magkakaroon ako ng energy saver. I-convert ko muna ng, ito energy saver, ES, energy saver. Gagawin ko muna ng DC para yung patay dito sa kabila na hindi ko ginamit at ganun din ang patay dito, walang problema kasi naka-DC ako. Naka-DC. Ngayon pagka naka-DC na, continuous na, pwede nang magsaksak dito ng anything, no? Kaso lang, DC, ang ating mga equipment, mga electric fan, refrigerator ay AC, i-convert ko ulit ito ng AC na ikababalik mo ngayon, ibabalik ko ulit ng 240 o 220 volts. Di gagana na ulit. So, abangan nyo, hindi pa naman ako sure. At yun nga, kumuha nga tayo sa ground. Kung mayroong positive dito sa ground, ay di, ayos na. Siyempre, ang ano bang nandyan sa ground? Ang positive, negative dyan. Lalo na yung mga silver, copper, iron, mga zinc nandyan sa lupa. So, posible talaga na mayroon ditong mga positive ions na mahihigop. So, sakali mapakinabangan natin. So, itong ang gagawin ko. Abangan nyo. So, abangan nyo sa susunod na mga video. Testing naman ang ating gagawin. Huwag kayong magpahuli. Kaya mag-subscribe kayo. I-click nyo ang subscribe. I-click nyo rin ang notification bell. So, kakuha tayo ng mga positive ions mula sa ground. So, abangan nyo at para ma-update kayo, yun nga, nakasubscribe kayo. Kaya, yun ang susunod. Kung mapanood nyo yung, kung sakali, makasave tayo ng kukunti, dahil lang kumuha nga tayo ng mga positive electrons or ions mula sa ground, kung makasave tayo, wala nang explanation doon. So, pagkapanood mo sa video na ito ay bago pa lang, so, ibig sabihin, wala pa yung testing na video. So, abangan mo na lalabas. Madali lang naman tingnan yung kung nasaan yung video. Click mo lang yung channel. And then, pagka-channel, click mo yung videos. Nandoon yung mga hiliran ng mga videos. So, makikita mo kung ano yung mga kahiliran magkakatabi ng mga videos. Ngayon, kung pagkapanood mo sa videong ito, matagal na, ilang buwan na, ibig sabihin, nandyan na yung video na testing na ang papakita. Halimbawa kung magkano ang na-save, magkano reading sa isang araw, magkano sa reading sa isang buwan, kumpara sa may nakakabit nito, wala nang explanation ng ganito. So, ang testing na lang ipapakita natin. Kaya, dapat nakasubscribe ka. So, yan po mga kababayan. Salamat po.